This is Zellerbach Hall on the University of California, Berkeley campus. In rehearsal right now on the Zellerbach stage is a ballet called Invisible Cities, featuring several dancers and a robot run by a computer. We tend to think of computers as number crunchers, doing spreadsheets and that kind of thing, but in fact computers are increasingly being used in dance, music, theater, and art. Today we take a look at computers and the arts on this edition of the Computer Chronicles.
The Computer Chronicles is made possible in part by McGraw-Hill, publishers of Byte magazine, and BIX, the Byte Information Exchange. In print and online, Byte and BIX serve computer professionals worldwide with detailed information on new hardware, software, and technologies.
Welcome to the Computer Chronicles. I'm Stewart Cheifet, and with me this week is George Morrow. George, I want to show you some very lovely sketches here. Take a look at these pictures over here. That's one of them. There's another one. It's all done by the same artist, and you can see a kind of distinctive style.
Very
here.
distinctive.
I want to show you a picture of the artist next.
Okay.
A plotter hooked up to a computer. Okay, now there's a human being involved, of course. It's this artist, Harold Cohen. That's, in fact, a color example of the kind of paintings done by his computer system. George, some artists say computers and the arts don't mix, apples and oranges. Very bad idea. What do you think?
I disagree, Stuart. I think they're getting the hardware mixed up with the software. Look at what happened with the movie Star Wars. You had effects created by artists working with software that would have never been possible otherwise. And in art, there's a lot of repetitious tasks in dancing, things like that, rehearsals. And in repetitive tasks, computers can be a marvelous tool when the software is done by the people that are involved, the artists, and not some computer scientist.
George, today we're going to take a look at several examples of how computers, hardware, and software are used in the arts. We're going to begin by going back to that robot ballet I was talking about before and see how computers and robots are used in the world of dance.
This performance of Invisible Cities is an example of the new collaboration between the human dancer and increasingly human robots. The programmer for this piece was Margot Apostolos, who first got the idea from watching a robot used in a Veterans Hospital research project.
When I was at Stanford, it was just the curiosity myself to see if a robot, something that mechanical, and I saw it as being very staccato in its actions. The movements were to me, quite linear. There were constant speeds, and it just didn't seem to be moving very beautifully.
Margot has since produced several robotic dance works of her own, some with and some without human partners. And she's discovered that robots can make a lasting impression.
Response is mixed in that the critics, insofar as my San Francisco performance with a dance company, the robot actually upstaged the dancers, got much better reviews in the papers, and the critics couldn't keep their eyes off the robot.
Another artist who became intrigued with robotic movement was Pamela Green at Stanford University. Her piece, entitled Animal, Vegetable, or Mineral, began as a costuming project.
The form was moving, and it reminded me of an animal form moving, particularly a bird. And so my first hunch was, what if these things were to really be birds? And then I tried that out in my first experiment, and it was too simple.
Pamela's work is for a single robot arm, which she programmed to move within an interactive environment. Animal, Vegetable, or Mineral is only about 8 minutes long, but it took a month of programming to successfully choreograph.
It just seemed to me that I didn't want an entirely passive robot with things happening to it. I wanted to, the name of the piece is Animal, Vegetable, or Mineral, and I wanted to explore in that what it is that gives something a spirit of animation, and at what point do we realize that something is animal, vegetable, or mineral.
Joining us in the studio now is Eddie Dombrauer. Eddie's president of Dom Dance Press and the developer of a software program for choreographers, George.
Eddie, give us a little on your background and how you came to write this program.
Well, I both studied dance and computers when I was in college, and after I...
Very unusual, right?
Yeah, very, very rare. I graduated, and then I received a grant to go to England and study computers and choreography. At that time in 1980, there wasn't a whole lot being done, especially not on small portable computers. Everything was being done at the research level. And so I worked a little bit on human animation because I felt that was a better way to represent notation.
Your dance representations are all visual then?
That's right, so the dancer can just watch a human move a little bit how like they watch a dancer move in a studio.
The problem is, I take it, trying to find the words to describe the infinite number of dance movements and so on, and instead of trying to create that language, you're just putting the movements on the screen.
That's right. It's too cumbersome to look at it on paper.
Okay, well,
let's take a look at it.
Okay. First, we're going to look at the editing system, which I developed somewhat backwards in trying to keep the figure movable and looking like a human. I had to figure out a way to move it myself, so I came up with this scheme that's menu-driven. So if we want to move the arms, we simply go to the arm and raise it with the arrow keys, or unraise it.
So there's a lot of animation going on here.
That's right. This is very much like an animation tool. As a matter of fact, I'm doing a product for Electronic Arts. It's Earl Weaver Baseball. Oh. And I actually did all the baseball animation with this, so it's not restricted to just dance movements.
Now, when you get through with these moving the figure around, programming the way, you actually end up with a dance sequence then.
That's right. You actually save each individual frame. You save a frame, you move it a little bit more, and you create the next frame very much as an animator would.
I see. And you have one of these that you can show us?
Yes, I do.
Okay, this is really a dancing word processor. I mean, you're building a dance document, if you will, with dance steps instead of words.
That's very much the case. A lot of the techniques and a lot of the way that we describe it to the users is as if it were a word processor.
Yeah.
Eddie, how would this tool be used? Is this tool be used both by a choreographer and a dancer?
It would be used by choreographers to put their work in, or teachers, but mostly I see it being used by dancers in order to learn things that aren't accessible to them because of their location.
What are we seeing on the screen now, Eddie?
This is what we call our introduction dance. This pretty much covers a lot of things in the dance world we call a pedestrian move, which is walking, which is one of the more difficult things to notate, and it goes into some ballet steps here. And so this part of the system, which is I think the most commonly used part, works a lot like a videotape recorder. You can just tell it to go, you can freeze frame and step through single frames. You can do what we call a walk around and look at the figure from the back, so in case the figure is not real clear what it is from the front, you can watch the figure from the side or the back or up or down.
So you can, if you want to look at the figure as it's going through this from a back view, you can do that.
That's right.
Which is more flexible than a videotape would be.
Definitely so. You can also edit things, which you can't do very easily if you wanted to make it a little easier for a less advanced dancer.
So the choreographer might use this to create the dancer might use it to learn the steps in the dance.
Definitely so. It has a repeat feature so that you can repeat small sections of it over and over again without tiring a person out.
What kind of feedback are you getting from the industry? You've got some out on beta site tests?
Yes, we have 15 out on beta test sites, and we're getting very positive feedbacks. They're mostly teachers and universities that seem to be using it, and we're getting very positive feedback that they think that this is a fairly useful tool.
This is an example of a professional creating a program instead of a programmer.
Right. The dancer part came first.
Right.
What are you going to show us now? I think we have a grand finale here?
Yeah, this is something I just did just to show that it also does things that aren't strictly ballet. This is a little breakdance thing I threw in.
Okay.
Just to show that it can do things on its head.
It sure does. Well, Eddie, thank you very much. It's very impressive. Good luck with it.
Thank you.
In just a minute, we're going to take a look at a software program that lets you direct a play on your computer screen, so stay with us. Joining us now in the studio are Larry Freelander, professor of English at Stanford University, and next to Larry, Charles Kearns, a project leader in the IRIS program at Stanford. George?
Charles, tell us just a bit about IRIS and how it works at Stanford.
IRIS is a part of academic computing at Stanford, and we had a special project where we worked with faculty members to develop instructional courseware. And this is one of the projects that we developed.
So you act as a resource for people who aren't entirely computer literate or don't have all the equipment they need for a project.
That's correct. We supply equipment and programming expertise.
Larry, what is the program that you've developed?
Well, this is a program to help students who have no theatrical background and who are in large classes who are studying Shakespeare or theater and mainly only can read the text, have no access to a stage. This is to help develop their imaginations for staging and spatial relationships, so that when they read, they can also, in their mind, create a scene. I'm going to show you a scene a student has created, and then go back and show you how it's been made. So I've just accessed it, and it's going to play. It's a scene from Hamlet, and in this scene, Hamlet and Ophelia are attempting a reconciliation. There's father coming down and trying to check out the action. Hamlet is speaking to Ophelia. This is coordinated with the text, and Ophelia is not interested, and she's going to walk away. And I think for some reason we have, oh, there we go. And the scene is now over. Now, in order to do this, the student has started from the beginning and picked stages and actors and props that he or she wants. For example, the same scene could be done with...
so this could have been an assignment to read the text,
exactly,
and then to create movements on the stage based on that text.
Yes, the student would have to make all the important decisions that a director would make and that an actor would make. Here, the student has put it on a stage
now
to
you're on a
help
grid
himself.
stage,
Right.
And now you can give this as an assignment. Rather than
right, and everyone can discuss it together. Now, the way this happens is that there are 4 positions the actor can be in. If I click on the waist, I move it either standing, sitting, or kneeling, or lying down. Or I can move the head.
Suppose I wanted to...
Whoops, you see the head won't move that way because it's not a real way, not a human way, but the head can move there. If I click on the feet, the character will move and turn in the direction of the...
So this isn't quite icon-driven, it's more almost positional-driven, without having to have a keyboard.
Right. The idea is, and Charles was very clever in the programming, is that simply by using the mouse and clicking on, if I click on the knees of the character, I turn the character around. I click on the head, it will turn the character's head. If I click on the feet, it will turn the feet. And if I click on the stomach, it will move the character down.
Roughly, what was the division of labor on this project?
We actually worked very closely. Charles did the actual programming, since I'm not a programmer, but we had a lot of decisions to make in designing.
You were the designer?
Yes, basically. And we also had a graphic artist, Marge Boots, who's worked a lot with Macintosh to help us.
This is just fascinating.
Yeah, do you see an actual director being able to use a tool like this and blocking out a play, for example?
Yes, I think it'd be useful when there's a large scene and the director has to manipulate a lot of characters and to work out the traffic beforehand and the basic movement. It's very important.
At least at this stage, then it's more of a tool for a director. But if it were taken to its logical conclusion, that is, if it were developed, it would actually serve a director as a way to provide rehearsal, wouldn't it?
Yes, and it also could be a way of recording what happens in rehearsal. Right now, the stage manager writes everything down.
And as in the choreography example, the actors could look at this and figure out what they're supposed to be doing in terms of their stage movements.
Yeah, but the business of keeping track of everything.
Yeah. Well, one actor only has to keep track of one actor.
No, but you can keep track of it instead of having people write down everything that was in
the same problem as in choreography. Right. And you can also move the props around and change props.
Yes, you can move the props anywhere you want. You can change them. You can make this an outdoor scene. You can have characters in modern dress and modern stages.
Stuart, this is an example where you're enhancing creativity, not putting a chain on it.
Gentlemen, thank you very much.
Thank you.
Now, one new art form which necessitates the use of computers is holography. And we have a report now on a woman who uses a computer to create 360-degree holograms. Wendy Woods has the story.
Since television is a two-dimensional medium, you can't see what we see, a stunning, moving, three-dimensional image. Holographic artist Sharon McCormick makes these images by first capturing computer graphics on film. The process of transferring these images to holographic film is tedious and exacting, and for that job, Sharon uses an Apple II. The Micro is programmed to drive the optical printer, which makes the holograms. Exposure time, running time, the stability of the optical printer, and the ratio of the two laser beams, which are combined to create the hologram, are all software-driven.
Because of the computer, I'm able to input all of the different parameters for making the hologram from a keyboard. It's wonderful.
The original design is also created on a computer. Just a few years ago, creation of a rotating, textured image like this one required the power of a Cray supercomputer. Today, this is done on a small graphics workstation.
With the computer, I can have whatever surface I want on it. I can change the scale, I could change the perspective, I can choose the lens in the computer to gear it perfectly for my optical system, and never have to carve anything out.
These holograms in the round are certainly exciting, and also exciting is a new process called embossing. Techniques are being developed to put holograms like these directly onto non-photographic surfaces, which will put more computer-generated holograms into the public eye. In San Francisco, for the Computer Chronicles, I'm Wendy Woods.
With us in the studio now is John Burke, conservator with the Oakland Museum. Next to John, Stacy Mitchell, CEO of Great Wave Software. George?
John, conservator is not the most common occupation, nor is it obvious how a conservator uses software.
Well, they used to call us restorers. We're the people in museums who take care of the objects. We do so many other things besides restore them. We preserve them and conserve them, like cultural artifacts and our cultural heritage.
This would be paintings or pieces of sculpture?
Paintings, pieces of sculpture, works on
virtually
paper.
Any piece of art.
Cultural art.
And how do computers get into your work then?
Well, documentation is very important in the kind of work that I do. We have to know the condition of an object at all times. We need to know what is done to it, what has been done to it, what changes we affect, and how it may
So lots of detail and lots of tracking.
Exactly.
And you have a piece of software here which helps you do that.
Yes, well, I'm using Microsoft File as a database. I'm coupling that with a video digitizer called MacVision to keep a picture of the object that I'm working on.
So show us how you use it. You're using off-the-shelf software here, really in an art application.
That's right.
And show us how you use it.
Okay, this is basically number of objects here on the screen. When I receive them, the client, their address, accession number, the artist, the title.
Okay, so that's your database of the pieces of art you're working on.
Exactly.
But you've coupled this with some video data, too.
That's right. Let's look at one of those reports.
Sure.
This again has the other information, the owner, the date, etc., etc. But it has a digitized picture of the art object and where something was missing. This was replaced. It's much easier for us to show an image on the screen than it is to describe in words.
So that's the damage to that particular painting
Exactly. I have other types of things in here that you can see. This is an object as opposed to a piece of paper. The digitizer works with 3D pieces as well as two-dimensional ones. There were tape stains on the margins of the print. I just drew those in and then noted them at the bottom where the tape stains were. We also do a verbal description of our treatments.
So you're able to mix text and video information together in this.
And we take photographs for more specific information.
And these are cracks?
You can see the cracks on the base, exactly. It's much easier to access this kind of information being computerized.
So this is really, once again, like the dancing or the acting we just saw before, George, another way to not have to come up with words to describe these things, but really record the real thing.
Yeah. Mixture of video and text.
So the last piece I have here is a Balinese mask that has some damage on the top. You can see, and the size has been noted on the side, so you can get a sense for the size of the piece.
Okay, and you could print out a record of that to show to a client or something?
Happen to have that's the report that was done. You can see how it prints out very much like it is on the screen. And this is the object.
And that's the real piece of art
that was used.
That's very interesting.
That's great. And you really couldn't do this without something like this software.
Or nearly the detail.
No, not as easily. We certainly could use photographs, but they're not as convenient to access as...
John, I'm going to ask you to unboot there and get your software out of there as we turn to Stacy here and go to the world of music now. You have something called terpsichore, and that's as confusing as being a conservator. Tell us what that is.
Okay, terpsichore is the name of a work of music that was compiled by Michael Praetorius and first published in 1612. What it is terpsichore is the Greek muse of dance, and what it is a collection of 312 dances. And what we have on our computer program is author Richard Ray has put together a compilation of 181 of those dances onto computer disk and designed the Renaissance instruments to play with them.
Okay, can we load up terpsichore here? Can you reach over, or maybe John can help you, whatever way to do that here?
There.
Okay, this will take a second or two to load. So tell us what you've done now with terpsichore, Stacy.
Basically, it is an addition to Concertware Plus, which is our music program that we have. And what it is basically a set of music for the Macintosh. And what it is people can go in, they can see the Renaissance music. 80% of this music has never been published in auditory form before. It's always been on the library shelves. And
So no performance, no records, no tapes of this music.
Right. But it's there in writing.
And these are the old instruments also, which aren't either readily available.
Right. A lot of those are...
And are you recreating the sounds of those instruments as well?
Yes, we are.
I see.
Yes. And what happens...
What are we seeing here now, Stacy?
Let's see. What we have here is we'll have actually a piece of music that we'll play, and we have it working with the Casio CZ101. It's designed also to work with Concert plus MIDI.
But that's talks to the Mac talks to the Casio over a MIDI bus, right?
Yes. Yeah, basically.
Okay, so you're doing what now? Loading in a piece of music?
I am loading in one of the pieces of music, and you'll see a lot of different Renaissance instruments on the screen, which Richard has designed to sound as much like Renaissance music.
And what are we listening to now?
This is called the Ballet de la Roine.
And the instruments?
We have on this piece, we have a racket, a recorder, a crumb horn, viola da gamba, regal lute, bombard, and a true harpsichord.
So
well, let's hear the music just one second here. Let's see. Okay, could you stop it a second, Stacy, so we can sort of talk and not fight with the music? Sorry, George, you're going to ask your question.
How many instruments can you play at one time in this environment?
Okay, it depends really on the synthesizer which you have. The Casios play 4 instruments at a time.
I see.
You see here 8 instruments off to the side. You can have an orchestra of 8 different instruments. Some of the Yamaha synthesizers will play all 8 at one time. But here you only have 4, so you have them trading back and forth.
What's the kind of application or market here? Who's going to use terpsichore, and what is it doing?
Basically, the Renaissance music enthusiasts. Some of the universities use it for their early music programs. Anyone who wants to play around with music. Some of the just consumers who like to listen to this type of music.
And the unique contribution of the computer here is what?
Is that it's been able to record something that before has not been recorded in any sense.
So you can take instruments that virtually are almost only a few left in the world and recreate the sounds associated with them and actually be able to recreate a performance as it might have occurred.
Correct. Or you can go and you can rearrange instruments and create your own type of performance with
you could
the same
orchestrate
music.
this using the software. And of course you can play it without a synthesizer, right? Just using
through the
Mac
Macintosh.
alone. John, have you ever thought about designing software to do the kinds of things you do in artwork rather than using off-the-shelf stuff?
Actually, yes. We've been talking about doing the kind of documentation that I showed you using artificial intelligence, entering a picture of the object and its exterior dimensions, and then pointing to various pieces, parts of damage, sizes, etc., and having the computer figure out the type of damage, where it exists, and write documentation for us.
Making yourself more productive.
Exactly, making a number of people able to do something that up to now takes an expert to do.
All right.
John and Stacy, thank you very much. George, we've seen some pretty good applications of using computer software in the arts, haven't we? We hope
they really do
enjoyed
belong there.
And we'll be back in just a minute with this week's Computer News.
In the Random Access file this week, Apple has announced price cuts in the Macintosh line, saying component prices have been dropping. The lower prices affect memory expansion kits and hard drives, in addition to the Mac SE and the Mac 2. Here are some sample prices. The 2 megabyte SE with a 40 megabyte drive is now $4,369. A 4 megabyte Mac 2 with a 40 megabyte drive is now $7,369. And a Mac 2X with an 80 meg drive is now $7,869. Generally, good reviews are coming in on the new Mac SE30, a souped-up version of the old Mac SE featuring the faster 16 megahertz 68030 microprocessor. The SE30 is being described as a Mac 2 in an SE box. The new SE30 has a different slot architecture called the 030 direct slot. That means that expansion cards designed for the old SE cannot be used on the SE30. However, the new slot does open up the SE30 to the new bus cards designed for the Macintosh 2. Jasmine has announced it will soon start shipping its new erasable optical disc drive. It's a 5 1/4 inch drive with a 600 megabyte capacity. Average seek time is 50 milliseconds. The price is under $5,000. And Verbatim has announced a 3 1/2 inch erasable optical drive, claiming average access time of 30 milliseconds. No word on price or shipping date. Unisys has introduced what it is calling the world's first desktop mainframe called the Micro A. Unisys says the desktop computer can run MS-DOS programs, or it can run programs written for Unisys Series A mainframes. Lotus has unveiled its new Magellan program. It's a hard disk management program that lets you search for files by keywords, phrases, or concepts. The program also lets you combine files or portions of files into a new single file. Magellan ships in April. List price is $195. Meanwhile, Lotus got some bad news on the earnings front. Fourth quarter net was down over 60% from $23 million in 1987 to only $9 million last year. However, yearly net sales were up 18%. Finally, Hungarian gamesman Erno Rubik has said niet to a computer version of his famous puzzles, including the classic Rubik's Cube and the new Rubik's Clock. Mr. Rubik says a puzzle must be touched and felt, and that you can't do that yet on a computer screen. That's it for this week's Random Access File. I'm Cynthia Steele.
The Computer Chronicles is made possible in part by McGraw-Hill, publishers of Byte magazine, and BIX, the Byte Information Exchange. In print and online, Byte and BIX serve computer professionals worldwide with detailed information on new hardware, software, and technologies.
For a transcript of this week's Computer Chronicles, send $4 to PTV Publications, Post Office Box 701, Kent, Ohio 44240. Please indicate program date.